Welcome and thank you for standing by. At this time, all parties are on a listen-only mode until the question and answer session of today's conference. Today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the meeting over to Mr. Ben Maurer. You may begin.
Great, thank you. Morning, everybody. My name is Ben Maurer, as Troy mentioned, and it's my privilege to welcome you to our webinar on the Marine and Hydrokinetic Risk Management Framework today. I'm a marine system engineer working with a water power program here at the U.S. DOE in Washington, D.C., and it's our job to advance MHK technology towards commercial viability. As you may have noticed in the recent international news, this is not an insignificant challenge, so the DOE has invested in a tool to help guide developers in identifying and managing risk, all different types of risk, as you'll see today. It's our intention that this investment repay itself many times over and increase reliability and survivability of future MHK deployments. The framework's been developed by David Snowberg and Jochem Weber of the National Renewable Energy Laboratory in Colorado. And they've leveraged lessons learned, and they've used best practices from land-based wind, offshore wind, and previous marine and hydrokinetic projects both here in the U.S. and internationally. And they've had the completed framework reviewed externally by Claudio Bittencourt of the certifying agency DNVGL. You can expect to see elements of this framework required in future DOE funding opportunity announcements and in future funding agreements, specifically the checklist and the register, both of which will be described in more detail during the webinar today. And after this webinar, you'll have the opportunity to provide feedback on the framework for the next 5 business days before its scheduled release in January of 2015. So I'm going to end on a personal note by saying I've been the technical lead on this project for the past year, and I'm really pleased with the work that Dave and Jochem have delivered here. I think it's been an excellent return on investment for the DOE, and I'm looking forward to seeing it be put into use. So without further ado, I'll turn it over to David Snowberg and Jochem Weber of the National Renewable Energy Laboratory to walk you all through the MHK Risk Management Framework. Thanks.
Okay, thank you, Ben. This is David Snowberg at NREL. This is the outline of today's webinar. We're going to start by describing the MHK technology development flowchart, which is the high-level development process for managing risks. Then Jochem will define and discuss the technology readiness level and technology performance level, the TRL and TPL, and how that's integrated into this framework document. Then I'll discuss the 12 specific risk management activities that are identified in the framework document. And one of those is a risk register, for which I'll go into additional details and show an example template that we've developed in Excel for maintaining a risk register. And then we'll discuss collecting and using lessons learned and how those can be used to manage risk as well as to improve the overall development process. And then Jochem will discuss Appendix A, which is a risk management checklist for full applicants. And then I'll briefly go over Appendix B, C, and D, which is the failure trend analysis and outline bibliography and publicly available MHK lessons learned. And then we'll take questions from any webinar participant that may have them. So this is the technology development flowchart, and this is the foundation of the risk management framework that we've developed. The risks are managed in this flowchart both through the overall process of having a development flowchart, as well as specific risk management activities that are prescribed here, for which I'll go into further detail. Each one of these cycles is based on a technology readiness level or technology performance level increment, and this cycle can apply to both the overall system as well as component level development. So this process starts by assessing the current TRL and TPL of the component or system, and assuming it's not at the final target, then you define what the targets are for the current development cycle. The risk management activities are based on what the TRL is for this current development cycle, and then design begins following that. The design and risk review here is a gate in order to check that the design is adequate before building it, as well as that the risks are acceptable. Assuming they are, the equipment is built and integrated, and then there's another review here pre-test and risk review. And there again, the risk management documents are verified that they're complete and adequate before beginning the commissioning and test for the system or component. At the end of this development cycle is the collecting of lessons learned, which then feed into improving the risk management plan. And then the process repeats until the TRL and TPL levels are at the final target. So everything presented in today's webinar is based on the December 9th, 2014 draft framework document. So please see that framework for additional details on anything presented today, as well as citations to external references for the material presented. Now, the first step is the assess current design TRL and TPL, which Jochem will discuss in further detail.
Great. Thank you very much, Dave. And a welcome from myself as well to everybody who's online. As mentioned previously, the risk management framework is intended to be used for a variety of technology development steps. These can be at different stages of the development. So we wish to have the applicant describe what kind of a technology development step is being undertaken in this particular activity. Obviously, this step is to lead to some progress in the development, so we're using development progress metrics to describe this step. These are technology readiness levels and technology performance levels. The technology readiness levels are associated with the maturity of the technology, and the technology performance levels are associated with the techno-economic performance of the technology. The diagram or the graph that you see here is merely a simple two-dimensional expression of a plane, which is and the abscissa, the technology readiness levels, and at the ordinates, the technology performance levels. And as one representative example, we have the yellow arrow in the middle, which could be one technology development step that is relevant for the application for this risk management framework. But of course, the developments, the individual steps that are undertaken, they could equally be purely an increase in technology readiness level or purely an increase in technology performance level. The technology readiness levels metric is well known and has been used for some time. We are adopting clearly the technology readiness levels definitions of the DOE. We are, for example, we have TRL3, we have analytical and experimental proof of concept completed at TRL7, for example. We have full-scale demonstration completed. Then the other metric is the technology performance levels. They are defined again in 9 values, which are grouped into 3 groups: low, medium, and high. Just to recall, these express the techno-economic performance capability of the technology. So low characterizes technologies that are not economically viable. Medium characterizes technologies for which some features are characteristic to be potentially economically viable under particular and supportive market conditions. However, technologies or conceptual aspects need to be improved to become fully economically viable. The high range, that's the group in which technologies are economically viable and competitive as a renewable energy form. And we go a little bit deeper in this group. We'll look at the 3 different levels. So at 7, we have competitiveness with other renewable energy sources given favorable market conditions. So this would be situations in which technologies, renewable energy technologies, are being rolled out at the beginning where maybe something like a relatively strong and not sustainable for a long-term feed-in tariff is applied, say, for the first 5 years to roll out the technology. At technology performance level 8, we have competitiveness with other energy sources given sustainable support mechanisms. So these would be situations in which maybe wind was 5 to 10 years ago. Now wind is very close to being economically viable without support mechanisms. And that's what we have in mind. So the best techno-economic performance is when the technology is competitive with other energy sources without any specific support mechanism. So as I mentioned, these two metrics are being used to describe the technology development step. And the technology readiness levels are particularly important because the development needs to go through all 9 of these. This might not be the case for the technology performance levels. And Dave will be using the technology readiness levels as an indicator for the level of detail at which the risk framework activities are being conducted. And here I'll pass back to Dave.
Okay, thank you, Jochem. So the specific risk management activities begin here in this process step, and those are based on the TRL and TPL that are defined in the previous process. And then just to show that there are these verification gates where these diamond decision blocks are used to verify that the risk management is completed at that point. So this is Table 3 from the framework document. And the first 9 columns here prescribe which of these 12 risk management activities are required at specific TRL levels. So if there's an X in the column, for instance, column 1 here at TRL 1, each one of these activities would be required at a TRL 1. And then, as you can see, at a TRL 5, at that point, all the risk management activities identified in the framework part of that development cycle. Over here on the section that refers to the framework section reference. So now I'll go through each one of these 12 risk management activities. So the first one is the risk management plan, and this is defining how the risks are managed throughout the development cycle. This MHK framework document can provide the foundation for this risk management plan, or if your organization already has risk management in place, and that could be used in place of the framework if it meets or exceeds the requirements outlined in this framework. Section 4.2 is the project plan, and this project plan is just how the project is managed throughout the development cycle. This can help to identify some of the dynamic elements that can influence project success. It's recommended to use the Project Management Institute's project management body of knowledge areas within the project plan, 10 different knowledge areas, and reference the MHK framework document for further details on that. Section 4.3 is the risk register, and this is a comprehensive list of uncertain elements that could have positive or negative impact on the technology development. And the risk register will be described in more detail later in this webinar, in addition to showing the Excel template that we've developed. Section 4.4 is the design basis requirements. So this is the requirements to be met by the technology, which could include environmental conditions, design standards, controllability, etc. So the design basis should comply with the IEC 62600 Part 2 when it's released. That's the design requirements for marine energy systems. And there's also some other design basis guidelines referenced in the framework that can be used when developing the design basis document. The design basis loads is a subset of the design basis requirements, and this prescribes the load conditions that will be met as the design is developed. And here again, the same standards and references apply, as previously mentioned. The design description basically describes what the design looks like at its current development state. So this could be model code, descriptive text, build prints, assembly design in the form of CAD models or solid models. And this is describing the design at its current TRL and TPL level. This should be sufficient to build and integrate the system in subsequent process steps. Section 4.7 is the design analysis, and this is also at the current TRL and TPL development level. And it should be based on the loads from the design basis document. And here the analysis fidelity should be commensurate with failure risk, in the sense that the larger the impacts from having a failure, the more analysis that should be done to verify that things are as you expect them to be. Next step is from section 4.8. This is defining the survivability targets and strategies. So these are the targets that the conditions that the technology is expected to survive. And then strategy is simply the plan to achieve those targets. And here again, the same IC standard, 62600, should be complied with when it's released. And as well, there's a European Marine Energy Center published a reliability, maintainability, and survivability guideline that should be considered when developing these targets and strategies. Section 4.9 is defining the reliability and maintainability targets and strategies. So reliability targets could be quantified in terms of failures, mean time between failures, or mean time to repair. Maintainability targets could be quantified in terms of maintenance-free operating periods or other ways of quantifying maintainability targets for the device. Here again, the same standards and guidelines apply. Moving on to section 4.10 is the failure modes effects analysis, FMEA. This is a way of identifying possible system problems that could result from component failures. FMEA allows you to prioritize your failure risks by analyzing the different failure modes, the effects, and the potential causes. Section 4.11 is the technology qualification plan. This is the plan for verifying how and when the technology will meet the design requirements and targets. A test plan would be a subset of the qualification plan. The DNV publishes a recommended practice, A203, which has a section on developing technology qualification plan, which should be considered when reading this document. And the final step here is collecting lessons learned. These lessons learned should be captured both when they occur as well as at a formal debrief meeting at the end of the development cycle. These lessons learned can help to formalize institutional learning, to help avoid repeating mistakes, as well as building upon successes that occurred during the last development cycle. This is also used to improve the risk management plan. So whatever you've learned through the last development can be used to modify the risk management plan to make it more useful for your organization for the next development cycle. And more details will be provided on recommendations for lessons learned later in this webinar. Now we're going to go into some more details on a risk register. The risk register is a comprehensive list of positive and negative uncertainties that could impact the project. And the four steps here is the continuation of the cycle of processes that are involved in developing and maintaining a risk register. The first step is to identify the risks, and I'll go into further details on this in the next slide and recommendations on how to do that. After the risks are identified, they're analyzed, and in this case, I'm going to present a probability and frequency, probability and severity matrix, which allows the risks to be prioritized. The next step is to plan and execute risk responses, and this is a way of planning how you're going to manage that risk. The monitor and control risks is the ongoing process of maintaining a current risk register, detecting differences between reality and what the risk register states, as well as identifying new risks, in which case this process continues throughout the development cycle. So the first step here is to identify the risks, and this is where you identify the uncertainties that could impact the project. One technique is to use a risk breakdown structure, and this table here is an example of a risk breakdown structure. This is table 4 from the framework document. So the way this works is you have all sources of project risk at the RBS level 0. At RBS level 1 is broken down into technical risk, management risk, commercial risk, and external risk. And then within each one of those, it's further broken down into additional subcategories. So the purpose of this is just a way of categorizing risks into common categories and help to identify them, as well as to have common ways of organizing them. Technology life phases should be considered when identifying risk in the event that the risk is dependent on the life phase. For example, the risk during transportation of the equipment may be different than the risk when it's fully deployed. The risk owner should be identified at this point in the process as a person that's responsible for maintaining the risk management plan for that particular risk, as far as implementing the risk response strategy and monitoring any changes to that risk. Each one of these risks may be a function of the current TRL and TPL, or maybe a function of all future ones. So it may be identified here if it's pertinent. International standards can be used, as well as previous experience, to help identify risks for your particular development cycle. So the next process step is to analyze the risk. And here again, this is a probability and severity matrix. So this is the severity table, which is table 6 from the framework document. Here the risk types are broken down into different categories of safety, cost, time, scope, quality, environment, and regulation. And then within each one of those risk types, there's severities ranging from 0 up to 5, 0 being essentially no risk at all, and 5 being extreme, and everything in between. So each risk is given a severity within either one or more risk type categories. The next step is, within the analyzed risk, is to quantify the frequency of occurrence. This would be based on either on the expert judgment of the team, or it could be based on reliability data, if you have that, for a particular component. So here the frequency ranges from 0 to 5 as well, and 0 being less than 0.01% chance of occurring during a 1-year period, whereas 5 has a greater than 50% chance of occurring. Once you have the severity and frequency quantified, this is the risk priority number shown here, where severity on the x-axis and frequency on the y is multiplied together to come up with the risk priority number, the RPN. And then within the risk priority number, you have the green, yellow, and red thresholds for low, medium, and high risk priority number thresholds for the impact of that risk. So in most cases, negative risks, you desire to have a low RPN, whereas medium may or may not be acceptable depending on the circumstances, and under almost all circumstances, a high negative risk would be unacceptable. So that's where risk management would be used to either reduce or avoid those risks to lower the risk priority number. So, and the way that's done is by planning risk responses. So this is Table 8. We're following along in the framework document. So if you have negative risks, there's 4 different strategies described here. Avoiding the risk, which is ensuring that the risk cannot occur or cannot impact the project. Or you could transfer the risk, where you're transferring the risk to a third party, such as an insurance company. Mitigating risk is possibly the most common way of handling risk, and that's where you're actively reducing the probability or the consequence of the risk. And then finally, you can accept the risk. That would be doing nothing at all to try to manage the risk other than just accepting where it's at. And that could be done because it's already a very low level, or possibly you're accepting it in order to test some assumptions. And then the right 2 columns is all on positive risk opportunities. So positive risks are just uncertain elements in the project that could have a positive effect on the project. And the complement strategies to avoiding a negative risk is to exploit an opportunity, and complement to transferring a negative risk is to share it as an opportunity, and complement to the mitigate a negative risk is to enhance it as an opportunity, and then accept is the same in both cases. So other parts of planning risk responses include the timing and triggers. So that's when the response is implemented. So that could be based on a timing event or a trigger. A trigger would be, for instance, if you ever are over budget at a certain quarter, then you would implement a risk response or some other trigger condition. Residual risk is calculated using the same methods previously described, and that would be quantifying the risk after implementing the risk response strategy. It's also important to consider secondary risks that can result from implementing the response. So the response may create new risks that weren't already there, which are important to both identify and analyze, as they may create more problems than it may be worth to implement that strategy. And finally, a contingency plan will describe the action to take if the risk event occurs. Contingency plan is in the event that the response did not do anything to avoid it, to transfer it, mitigate it, and that the risk occurred. And what is your plan for dealing with that? So the monitor and control step is the ongoing process of detecting differences between the current situation and the risk register information. This is also the step where we would execute risk responses based on trigger conditions. And as new risks are identified, then you continue with this cycle of identifying, analyzing, planning. This continues continuously throughout the development cycle. Now I'm going to open up and review the Excel risk register template that we've developed, and anyone that has RSVP'd received a copy of this. So starting with the high level here, this is a template, a table in Excel. I will zoom in and go through one example, but just to show how this works, every row within this table is a unique risk that's been identified and analyzed, and responses are planned. So, and the fields above in each column are specific to each one of these risks. So the identify risk process goes through columns A through H, and then the analyze risk process goes through I through N, and then the risk response process begins on O and continues all the way through W. And finally, the contingency plan is the last column. So the data that's shown here is just hypothetical, just to demonstrate how this risk register can be used to manage risk. And all the data that's in here can be customized using the data valid data field tab within the spreadsheet. So using this simple procedure up here, all the information can be changed to be applicable to your organization. So the RBS is defined here in column C, D, and E, and then as well as external RBS levels in F. The risk owners are column J here. That's where you would put the people that you have in your organization that you're assigning risks to. And so each one of these fields can be modified to be appropriate for your particular application. So going back to the risk register, you're going to zoom in on this row 11, and if this was actually row 10 from people that received this as a draft template. So zooming in here, the first thing is revision date. Then the column B is determining what your RBS level 1 is. In this case, it's a technical risk, and it's a technical interface for RBS level 2. So what we're calling this risk named the shaft and generator connection. And just to describe what this risk is, jumping ahead to column 10, the shaft and generator, in this case, are made by different vendors. There's a possibility that the two parts may not mechanically interface with each other. So in this case, going back to the identifying risk process, we're identifying this at TRL level 5, TPL level 7. Each one of these is selected via drop-down box. The technology life phase, we've chosen this as the assembly and commissioning phase. And this has been assigned to Joe, the engineer, as the risk owner for this risk. So this is a negative risk, and we've identified it as a time category with a severity of 2, which refers to Table 6 from the framework document, and our team has identified the frequency of this risk as 3, which corresponds to something between 1 and 10% chance of occurring without implementing any risk response at this point. And so the RPN is simply calculated by multiplying those two together. Then moving over to column O, you may need to scroll separately depending on your screen resolution, but we are on column O at this point. So the risk response strategy chosen here is to mitigate the risk. The other options being avoiding it, transferring it, or accepting it. And the strategy is defined here in column P as doing a tolerance stack-up check. We're going to discuss at design reviews with each vendor before the PO is issued, and check a tolerance stack-up on each subsystem, and have formal design reviews with each vendor. In this case, the timing is before the PO is issued. That's the trigger condition for the timing that needs to be met in order to implement this risk response. So the residual risk is calculated based on what we expect by implementing that risk response. And here the severity has not changed, but the frequency, we believe, has decreased to a probability of occurrence of 1, which then has an RPN of 2 as opposed to where it began at 6. And the description of that response with some of the residual risk is there's still a possibility of errors being made with a tolerance check, or information could not be, it's possible that information is not clearly communicated with each vendor. So that there always will be some residual risk. And then moving on to column B, no secondary risks were identified. In this case, recommendations are to ensure that the design review is scheduled with each vendor. Tolerance stack-up is internally checked by engineering. And then the contingency plan, in case the situation where this risk management strategy did not work, in the event of that there is an interference problem, and you would reference the terms and conditions from the PO to describe the next steps to take. So this is just one example of how risk can be managed in this register template, and there's some others in this example, in this template that can be viewed. Now we're going to go back to the PowerPoint. Now I'm going to go into some additional details and recommendations on collecting and using lessons learned. The lessons learned are formally collected at the end of every development cycle, as shown here. And these are ways of identifying problems that occurred and identifying ways of hopefully reducing the probability or severity of that problem from reoccurring, as well as identifying successes and ways to build upon those for future development cycles. The input, the lessons learned that are created here is an input to the improved risk management plan process here, where everything identified within this flowchart and then within this framework can and should be changed, but it continues to be a current relevant tool for your organization. And then there's some different questions that can be asked during a debrief meeting to help stimulate discussion and bring about identifying different lessons learned. So this is Table 9 from the framework document, and this is just one way of collecting lessons learned of problems or issues. In this case, the issue is identified by name and a description, and then the impact of the particular issue is identified, as well as recommendations for improvement. And anything here in red is an action item with action items signed over here. This is a way of being able to capture and then track these lessons learned. Everything here is fabricated data just to demonstrate the use of this. So this is a similar table for identifying successes that occurred, and this is Table 10 from the framework document. And here the successes are named and described, and then the impact of that success is listed in this column, and then factors supporting the success identified here, as well as action items to follow up on that so that these successes can be built on subsequent development cycles. Now the next step, Jochem is going to talk about the risk management checklist for full applicants.
Thanks, Dave. Yeah. The idea behind the risk management checklist is that we felt it is important that already at the planning phase of a project, which is related to the application phase, sufficient considerations of the risk and risk management should be made. This will support the project plan in the application, and it will also plan the risk management activities during running the project. And we'll go through the steps that should be satisfied in this checklist and thereby applied by the applicant during funding opportunity application. So first of all, the applicant should provide a brief description of the system and components to be developed within the FOA project. Risk management strategies with reference to each of the following subsystems and project metrics should be specified. So we have lots of functionality of quite a number of relevant subsystems. These may be slightly different in your particular project, but this is the level of detail and thoroughness we feel is required for this. So the loss of functionality of these will be considered. We also need to look at loss of device. This might sound severe, but we all know that cases like this have happened. Further on, reduction of power, that we observed reduced power production during the test, reduced in comparison to what was expected or predicted. That there might be a low availability during the test. There might be an incomplete data collection. There might be a delay in deployment or commissioning or breach of safety requirements. So these examples that are being given here are customized for the main focus of application of this risk management framework, which is seagoing demonstration activities. However, these could be different depending on the technology development step you're undertaking as the risk management framework is expected to be applied to all of those steps. Secondly, in case you would like to use a risk management plan other than the one provided here, we would like to see that you can verify that it is of equal or higher detail and covers what is being proposed here. In the checklist already, you should describe the current TRL, TPL status where you are prior to 4, then at funding conclusion, and subsequently which step you're going to undertake in the actual 4 project and you're going to achieve in the period of performance of this project. What components and subsystems, if any, will be developed and tested in parallel to the overall system? This is an important aspect because many of the technology development activities can be effectively de-risked by component or subsystem tests. We'd like you to describe the preliminary survival targets and the strategies on how to obtain these. Finally, if you are at TRL 5 or higher in such a technology demonstration activity, it would be useful and is required here to describe preliminary targets for reliability, maintainability, and strategy on how to obtain these. Well, we would like you to list the planned risk management deliverables in the 4 periods, and you can look at table 3 in relation to this. To list the relevant standards to be used during the technology development under this 4. And finally, we would like you to specify the top 10 expected project risks that you can see and to analyze and do a preliminary risk management activity with these in the risk management spreadsheet just explained by Dave. So these are the activities that we feel give a good basis for considering risk at an early stage, which will have an impact into the overall project plan, as well as into the planning of the risk management during the project. We envisage that this provision and satisfaction of this checklist will relate to maybe an effort of 1 or maximum 2 days to do this. And at this point, I hand back to Dave for other annexes in the risk management framework.
Okay, thank you, Jochem. So now I'm going to open up the framework document and just briefly go over Appendix B, C, and D. This will be the last section of this webinar before we open up for questions. So Appendix B is a failure mode trend analysis. So the table here, table 11, identifies failure modes which are the same as the ones Jochem just mentioned in the full applicant risk management checklist for identifying your risk management plan for. So the severity definitions are defined in this table from 0 to 5. And this just provides a way of tracking failure modes either for a single project or a portfolio of projects added together. So these include loss of functionality for different systems, as well as how power production compares to expectations, availability, safety incidents, and with severities ranging from 0 to 5. The next couple of tables here are just hypothetical examples of how data could be collected for a given period. Period 1 is table 12. Table 13 identifies failures in period 2. And 14 is a third period. So this data, one way this data could be presented is as shown in figure 4, where all the different failure modes are shown here in the x-axis, whereas the y-axis shows the higher levels of severity going back, and then the z-axis shows the occurrence of each one of these failure modes. Figure 5 shows the trend across 3 different periods, period 1, 2, and 3, for one particular failure mode. So this is one example of how the data could be presented as trending through time. Appendix C is an outline bibliography on different risk management sources for standards, guides, and reports. Anything here that's shown with an underline contains a link to an external source, so you can click on that and it'll open up that external document. Anything that's not underlined is copyrighted and would be required to be purchased in order to view those documents. So some of the categories we have is certification and qualification guidelines, general and marine risk management, failure management, design and testing guidelines, safety management, TRL definitions, and then the last section is the miscellaneous reports, papers. The last appendix is on MHK lessons learned from publicly available information. These are all external websites that have published information on different news articles or other from other media on different failures of MHK systems. Some of the categories shown here: structural failures, breach of water integrity. Not going to go into any of these details right now, but the framework does contain this for reference. And then the last section here is some summary reports by manufacturers. So with that, that concludes our webinar today. Thank you for participating. Hope that you learned something about the MHK framework document that we've created. And at this point, we'll begin answering any questions that you have. And if you do have questions, please type them into the Q&A tab that's as part of the menu bar of this webinar. So after we have received some questions, we'll unmute the lines and request that the people who have a question can ask them. And then after we do unmute the lines, if you do have any background noise, please mute your line if you don't have a question to ask. And in the meantime, if you do have any feedback for us, please send that to us within the next 5 days for consideration with this framework document, because we will be publishing this in early 2015. And if you have any questions that aren't answered during this Q&A period, then please send an email to Samantha, and she will see to it that your questions are answered.
Okay, thanks everybody. So we'll see what kind of questions come in now.
So if we could have the operator unmute the lines for the participants, and then we'll begin accepting questions. So we do have some first question from Jim Brethel.
Jim, would you like to go ahead and formulate now your question so all the participants can hear it and will respond to it?
Sure. Hi, Jochem. Can you hear me okay?
Yes. Yes. Thank you.
Okay, great. Thanks a lot for the presentation. The one thing that I wrote there, it occurred to me during the presentation, or in my mind, the deployment and maintenance as well as recovery is an area where we run into technology that is at a very high level, TRL and TPL, and I feel like it perhaps might deserve to a higher visibility within the framework. I'm not sure. While I know the framework does handle it, and of course any risks involved can be dealt with the very detailed and useful tools you've given there, I just feel like at times we get in the industry, we are faced with solving like new technology where we get really focused on the task of getting our systems to work, and we perhaps have a tendency to leave that to last because we assume it is already at a high level of readiness, and when we get to deployment, sometimes we might get caught. We end up doing a lot of learning at that stage. So I just feel like it deserves, or maybe the same process, it deserves some visibility. Does that make sense?
Yeah, I think we understand the question or the comment. So I think you are pointing out that there should be a clearer visibility on that. This applies also to O&M activities. And as you said yourself, the other framework does cover that. Currently, it is not mentioned as a specific example, but it does cover it.
Yeah.
We may consider within the running 5 days of taking on board any improvements. We can see if we can find a place to mention this in the document.
Jochem, if I could just jump in there. This is Ben Maurer from DOE again. I think one of the areas that I really liked in the framework that you guys developed is the Appendix D, where there are lessons learned from industry. And if you were to go through those lessons,
right,
some of the media that's presented there actually discusses a lot of the troubles that there have been deploying.
Yeah.
So it mentions a few that I'm not going to name by name, but there's definitely information there on deployment mishaps, I guess, or challenges. So yes, the register and the framework have the ability to, and they don't call that out specifically, but there is information available through those links if you're looking for trends as a developer that should highlight installation difficulties.
Yeah, very good comment, Ben. Thanks a lot.
Thank you.
Yeah, thanks, Ben. Thanks, Jim. So the next question is by Bill.
So the line is open for Bill Starby. Bill, would you like to give us your question?
Sure, yeah. Thanks for the discussion today. Very interesting. Just a really simplistic question. Is the spreadsheet that you guys created, is that meant to capture all of the information that DOE is going to require in upcoming FOA announcements and proposal submissions?
Ben, would you like to answer that?
Absolutely, yeah, this is Ben Maurer. So this is something that is an ongoing process at DOE. At the moment, we're working on integrating this framework and this register into our announcements and our agreements. You can expect to see over the next few FOAs that are released, the checklist that's Appendix A will be required in some form or another. As far as turning in a register with a quarterly report or something like that, that hasn't actually been decided yet, what the burden is going to be on the developers. But we're going to be working within the bounds of this document as we ask things of the things of the awardees. So I think this will pretty much span all of that. Does that answer your question, Bill?
Yeah, it does. It's fine. Yep.
Okay.
Okay, thanks, Ben. Did that answer your question, Bill, or do you have any follow-up questions on that?
No follow-up questions. That's fine.
Okay, thanks. The next question is by Thomas Hudon, and his question is simply, will participants be sent a copy of the final framework? And the final framework will be available, it'll be published and available for download from the NREL website. So we can send that to everyone that has RSVP at this point, but it'll also be available for retrieval from everyone. Thomas, do you have any further questions on that?
Nope, that's it. Thank you.
Okay, thanks.
So there's a question by Ken Reinfrank. Ken, would you like to give us a question?
I think it was along the lines of what Bill asked. I was just wondering how the Department of Energy plans to implement this. In particular, I guess some of us already have a process in place, and I'm trying to figure out how we adapt a new process or adapt this one into ours. So it would be very helpful to know what the implementation plan is.
Ken, this is Ben Mar again. I would actually really like to hear from both you and Bill in that 5-day period, or maybe even after. You're more than welcome to call in, or I can get in touch with you. But yeah, I think that this wasn't meant to take the place of. This was meant to either serve as a risk management framework for projects that are without one. We do see a number of applicants for funding opportunities that don't have a risk management strategy or a risk management document. And the way that we've phrased, or the way that Dave and Jochem have phrased the appendices and the framework, it's meant to fill gaps where there aren't active risk management documents or practices in place. So they've been pretty explicit. I'm not sure it was mentioned in the webinar, but they've been pretty explicit in the document of saying this takes the place of a risk management plan where you have none. And DOE hasn't exactly decided how they're going to be using the framework moving forward, but we're definitely keen on having those projects that don't have any risk management start to acknowledge the risk that's out there and develop management plans to manage it. So, yeah, I can get in touch with you directly if you'd like.
So at the moment, we have no more questions in the chat window. If anybody wants to add further questions, please do so.
Does anybody have any further questions?
Hello?
Yes.
Hello?
Yes, speak away.
Jochem, it's Brian Holmes from Ireland.
Hi, Brian. Hello.
Hi, Jochem, and whoever your fellow speaker was.
Hey, Snowberg.
I'd ask one question, if I could, just for clarity. A lot of your document is compiling risk, but the techniques of actually how you decipher the risk is really the list at the back of in the appendix, and you list 9 different methods of possible methods of applying that risk. But I mean, you can't do all 9 of them. So is one of them particularly relevant, or how would one satisfy your requirements when there are so many options for how you decide what the risk is?
So which you said there's 9 of them, which
in the appendix, you list 9 methods of how to evaluate risk from DNV. I can't actually, I wasn't able to join the webinar, so I've been trying to follow it on the document.
I see.
But in the appendix, which you just went through at the end.
So as far as the Appendix C?
Yeah, there's a list of 9 different methods, from DMV to ISO to IEA, IEC.
Okay, so those are just meant for further reading on different risk management techniques and guidelines and such for additional reading on that. So some of those specific guidelines are called out within the framework, so I'd refer to particular sections of the framework that reference those for how they're recommended to be applied to this overall framework.
Okay, so I wasn't able to read the document beforehand, but you do actually specify it in the main text, yeah?
Yeah, there's in-text citations to different references and how they're recommended to be used.
Okay. Because if you had to read all 9 techniques, that's a lot of reading.
Yeah, no, I think what the framework really does intend to do is give maybe a not professional in risk management an opportunity and a structure how to implement that kind of risk management. And they do reference all the relevant and important documents in relation to this, but you don't need to be a master of all these documents to comply or to conduct this risk management framework as proposed.
Yeah. But can you recommend, somebody who hasn't done very much risk and I'm starting to get involved in it, can you recommend one particular document that you should read?
I wouldn't have one particular document. I'd maybe start with this framework document and then go off onto some of the references that it references within the text.
Okay.
Okay, any more questions? We have no additions to the chat window in terms of questions.
Okay, if there aren't any further questions, I think we'll conclude this webinar. And again, if you have any further questions that haven't been answered, or if you think of them after the fact, please send us an email.
Okay, thanks a lot to everybody, and goodbye from my side as well.
Thank you. It was highly informative.
Yeah, I hope that these slides will be available for people. That'd be great.
Yes, they will be.
Great. Thanks very much, guys. Appreciate it.
Okay, thank you.
Thanks a lot.
Yes. Thank you.
Thanks.
Bye-bye.
Thank you. This concludes today's conference. All parties may disconnect at this time. Speakers, please hold for post-conference.